Okay, so 6.2 or 6-2 bisectors of triangles. It starts with circumcenter theorem right here, and it says the circumcenter of a triangle is equidistant from the vertices. Vertices is a fancy word for corners of the triangle. So it says PD, PE, and PF are perpendicular bisectors. So what we're going to do is just trace those. Like if you have a color, that'd be great. Here, can you just take the doorstop out so it just thanks. Okay, so I'm tracing these perpendicular bisectors. So you have PD right here. So that's perpendicular to the side, and then it bisects that side. So this is the same length as this. And then PE, perpendicular to this side, and it bisects this side. And then PF right here, perpendicular, and it bisects this side right here. And then where those three lines intersect right here is called the circumcenter. Circumcenter. And then the circumcenter is equidistant to the corners, the vertices. So PA, PB, and PC. So PA, PB, and PC right here. These lines are the same length. So all the pink ones are the same length. So circumcenter of a triangle is equidistant from the vertices of the triangle. But in order to find the circumcenter, you have to use perpendicular bisectors. So that's why the vocabulary yesterday was so important, because we're using it a lot. Okay, so perpendicular bisectors intersect at the circumcenter. Here we can write this down. Perpendicular bisectors intersect at the circumcenter. And then that is equidistant to corners. Questions. Okay, and then we're going to go down on the page. I'm just trying to find my notes. So they were good. Okay, then moving down here, then we have in-center theorem. So in-center is where the three angle bisectors intersect, and it's equidistant from the sides. So here we're going to do similar thing with different colors. So AP, BP, and CP are angle bisectors. So AP right here, BP, and CP are angle bisectors. So that means that they're bisecting the angle, like this is the same as this. This here is the same as this on this side, and then this angle over here is the same as this on this side. Angle bisectors. Then that is equidistant from the sides. So PD, PE equals PF. So PD, PE, and PF, those are all the same length. So angle bisectors intersect at the in-center, and then that is equidistant from sides. Equidistant from sides. And then this here is the in-center. Okay, so then once you get that done, we're going to go to the practice page for 6.2. Okay, 6.2 here. Okay, so the first example, it says the perpendicular bisectors of ABC intersect at point G. Find the indicated measure. So remember, perpendicular bisectors intersect at the circumcenter. And that is equal distance to corners of the triangle. Okay, just like we did yesterday, we're going to highlight what we're trying to find for each one before we get started. So BG, I'm just highlighting the segment that it wants me to find. GA right here, it wants me to find this length. And then going down and doing the same thing for 5 and 6. It wants me to find PB right here. And then HP, this length right here. And then we're not going to do these here. Then up here. Okay, it says perpendicular bisectors of ABC intersect at point G, find the indicated measure. So here, the perpendicular bisectors are intersecting. So I'm going to highlight the perpendicular bisectors. So I have a perpendicular bisector right here, perpendicular, same on both sides. This looks like a perpendicular bisector here, same length on both sides, and then this one right here. And then where they intersect is the circumcenter, which is equal distance to each of the corners. So all of my pink lines are the same length. And then if this pink line is 9, then this one is 9. So BG equals 9. Okay, number 2 is similar. However, the circumcenter is outside the shape, which makes it a little bit harder to look at. But we're just going to trust the process. So we're just looking for perpendicular bisectors. So like this here, it looks like it's perpendicular to this line and bisects it. This looks like it's perpendicular to that. And then the other line back here, those are all perpendicular bisectors. And then from there, this is the length from the circumcenter to each of the corners. And all these pink lines should be the same length. It shows that this pink line is 11, so therefore GA would be 11. GA equals 11. Okay, and then 3 and 4, it says you and 2 friends plan to walk your dogs together. You want the meeting place to be the same distance from each person's residence. Explain how you can use a diagram to locate the meeting place. Okay, so first of all, we're going to draw a corner or a triangle. We're trying to find the same distance from each corner. So the way we can find the same distance from each corner is we can find the circumcenter. And we find the circumcenter using perpendicular bisectors. Using perpendicular bisectors. Okay, so for each line, we're going to draw a perpendicular bisector. So midpoint and then perpendicular line. Like that. Midpoint, perpendicular line, right there. And then find the midpoint and a perpendicular line. Pretty close. Okay, so there's our circumcenter, and then that should be equidistant to each of the corners. Obviously, there might be some human error, but the gist. Okay, the next one, the same idea. You open a donation center the same distance from each of the 3 stores shown. Use a diagram to determine the location. So we need it to be the same distance from each of the stores. Drawing a triangle. Then perpendicular bisector for each side. Close, I think. Then here is our circumcenter. And then that should be the same distance from each of the corners. And then for 5 and 6, says the angle bisectors of XYZ intersect at point P. Find the indicated measure. So for this one, we need to know that angle bisectors intersect at the in-center, which is equidistant from the side. Equidistant, distant from the sides. Okay, so in these examples now, I'm first highlighting the angle bisectors. So this here, angle bisector, angle bisector, angle bisector. Bisects the angles. Same as this here, same as this. Okay. Then it's equidistant to the side, so all these pink lines are the same length. It shows, thinking it's saying this here is 9, so therefore all the pink is 9. PB equals 9. Thinking it's saying the green line is 15. Okay, and the next one, same idea. Highlight all the angle bisectors first. Angle bisector, angle bisector, angle bisector. And then the 3 lines to each of the sides are the ones that are the same length. So it's showing that that is 15, so therefore HP equals 15. Okay, now we'll move to the next side. Okay, over here, we're just going to do 11 and 13. We're not going to do 12 or 14. Okay, so for this one, it says the in-center. The in-center is equidistant to the sides. Equidistant to sides. And it's created by the angle bisectors. So just like before, I'm going to highlight the angle bisectors first. Then this inner center is equidistant to the sides, so all 3 pink lines are the same length. It's saying ND, which is one of the pink lines, is this, NE is this, and it wants to know the length of NF. Well, all 3 of these pink lines are the same length, so I'm going to set these equal to find x. 6x minus 2 equals 3x plus 7. And then once I find x, I can just plug it back in. So subtract 3x from both sides. Yeah, x equals 3. And then once I get x equals 3, I can plug it into any one of these expressions because they'll all equal the same thing. So ND is 6 times 3 minus 2. 18 minus 2 is 16. So if ND equals 16, then NF also equals 16 because they're the same length. Okay, so 13, highlighting the angle bisectors again. And then this in-center is equidistant to the side, so these 3 pink lines are equal. And just like before, it gave us an expression for 2 of these, and we're trying to find the third. So we can start by just putting this equal to the expression for the other one. And we will solve. So add x over here. 3x minus 2 equals 10. 3x equals 12. X equals 4. Then once we have x, we just choose one of these. It doesn't matter which one because they're all going to be equal. So nk is 2 times 4 minus 2 is 6. Nk equals 6. But it's asking for nm, which will be the same thing. Nm equals 6 as well. Okay, that's all. So you have the homework on Schoology, so start there. Then work on Alex. Try to get 3 done in class today. I made a list of where you should start with Alex, like the easier ones, and they just kind of build into what we're doing today. So go ahead and grab a laptop and get started with the homework. Let me know if you have questions. Yes, go ahead.